Welcome to part 5 of this video series. We're looking at the repair and restoration of the Bush VHF 64 radio, and it is part 5, and this project is taking a lot longer than I thought it would. It's getting more complicated than I thought it would, but I'm not ready to give up yet, and we'll keep pushing on. There's no volume on the FM stage, and in part 4 I looked at the alignment of the FM stage. And the reason I did that was I wanted to test the intermediate frequency stages, and the alignment's a good way of doing that because you inject a signal at the start or the first IF stage and you monitor that all the way through to the output of the discriminator. So that was all working well. So to me, that tells me that the IF stages are okay. There's still no volume. What test didn't work was the last test where you try and get a zero current across. You've got those two resistors, and you monitor the current around that part of the circuit, which is around the output of the discriminator. That test is a proven test. It must have been done hundreds of thousands of times, really. So the fact that I can't get that current to zero suggests there might be a problem there. So I'm going to take a closer look around that part of the circuit. Other than that, it's really just pushing on and seeing how far I can get in this part. One of the questions I got from part 4 was clarification of where to connect the voltmeter and the ammeter for the alignment procedure. Now, I wouldn't have thought that anybody would actually attempt this procedure if they weren't sure without actually getting the service manual, because it's well documented in there. Nevertheless, the voltmeter connects across this array of parallel connected components, C59, R30 and C57. And the ammeter is connected between, well, at the center of this potential divider. These are the two 47K resistors, which are also connected across C59. And you take the center tap there, connect the ammeter, and then the other end of the ammeter is connected between C56 and C54. And it's this ammeter that you need to get down to 0, and I wasn't able to do that, so there may be a problem around here. So we'll take some further investigation there. In terms of injecting the signal, then that is done on the grid. That's pin 2 of V2, which is the ECH81 valve. So that's where you put the signal in. So that's why I was confident that going through this procedure would actually troubleshoot the entire IF stages, because we're looking at really at the very beginning and the very end of that stage. So hopefully that clarifies that connection, and I'll push on now and see if we can get this radio fixed. So I'm going to swap out the FM discriminator, which is here. They're very easy to get out. There's just 5 wires attached to the legs, and there's some bolts there, which releases the can, and then there's 2 screws which are holding the coil in. So I do have, I'm going to put the spare in, and this is good to actually have a look at how the spare is actually constructed. The reason I'm putting this in is the cores turn very easily on this. So you can just get a feel for how that is actually constructed. There is 2 very small capacitors on these, so they're actually a tuned circuit. What I'm thinking is, this might be okay, but on one of these FM coils, intermediate frequency coils, I wonder if either the capacitors come disconnected or it's gone short circuit, and so it's not tuning, so we're getting the attenuation that we're getting. That's my thinking. Now, I couldn't set this alignment up properly on the discriminator that's actually in circuit at the moment. Maybe nothing wrong with it, but I'm going to take it out to clean it up anyway, so I might as well put the this spare one in anyway. This is just the look at the can. So you can see that just bolts through to the base of the radio. So release those bolts, take the can away. First of all, I'll desolder the wires, and we're good to make that replacement. Then I'll go through the realignment. So, yes, in doing the alignment for the second time, and I missed it the first time, I've actually found what is the root cause of my FM problems. When I was changing the caps out, this C54 should be connected to the next tab up. So it's on the wrong point. It's actually connected directly to ground. It should be on the next tab up, which connects it to C56, which is the actual point B for the FM alignment. So that particular circuit, the output of the FM discriminator comes through there. So as it stands, it's just completely biased wrong. So I'm pretty sure that's going to be the root cause of my problem. What I'm going to do, I'm going to move that cap over, just one space, and then I'll just carry on with the alignment, and I'm pretty sure I'm going to get the FM volume back. So yeah, really frustrating, but these things do happen, and at least I've found the problem now. Well, that's typical of me. So what I've done, I've lost the video where I turned on the radio to test the VHF, and what I found was all the main channels were there. So that's BBC Radio 1, 2, 3 and 4 and a couple of other ones. Radio 1 was a reasonable volume, all clear. The other ones were a lower volume. Overall, the radio was a lot quieter on VHF compared to AM by a considerable amount. So there's still some work to do, but I was really pleased that I actually got to the point where the VHF was fundamentally working. Right, so I'm going to park the VHF for now. I'm going to revisit the AM because I made a significant change to the radio, and the radio was crackling a lot on the AM. I want to see if that can be addressed, and also revisit the alignment of the AM because it wasn't fully done. There was a slug in one of the IF cans which was a bit stuck. So I just want to have another look at that and think about what I want to do about that. I'm going to get back to the radio. I don't understand this radio. Last time I checked the AM, it wasn't particularly loud against the background noise, and there was a lot of scratching on the tuning capacitor, and the scratching was in a consistent place, several very staticky. Implied to me that was dirt, possibly in that tuning capacitor, because it was always at the same point every time I turned the capacitor. That seems to have receded now, and actually I'm getting really good volume actually on the AM. So it just seems to have sorted itself out. I'm going to realign it on the AM. I won't do that on camera because you've got to alter the primary and secondary slugs in each coil. So it's going to take a lot of fiddling to do that. Also, the slug in this can looks like it's damaged. I've been trying to free it up and using the right tools, and it looks like the thread or the recess for the tool has been damaged. So I'll swap that one out. Even though I think it's pretty well aligned, actually. It's probably in its optimum position anyway, but I'll swap that one out. For the scratching, I can't assume that that's just gone. So I'm going to blow some compressed air in the into the radio, and hopefully that's going to clear that problem. So I've got the compressed air blower somewhere. Just need to find that. Okay, so I'm not sure if that's made a lot of difference, but it's that's about the right volume for tuning. It doesn't seem to be very noisy.
Winning team.
And I get in TalkSport very well, actually. I still want to change this can because I do want to align this properly, because although there's nothing on long wave, that's quite noisy. Shortwave, there are some stations on there when I get a proper aerial, so I want to make sure the AM's aligned properly. But overall not bad. So I'll get that can changed, and then I'll get on with the alignment procedure. So that's the AM alignment done. I've got it on TalkSport now, so
It goes to Miller. Oh, they've got that one.
And hardly any volume in there at all.
To the ground.
That is really loud.
Of sport, keep abreast of the championship action.
Took a bit of tone out of it.
Big final, 66 kilogram.
Really, really, really happy with that. And it's not too noisy either. So I think in terms of AM, that's as good as we're going to get. I did think long and hard about taking that can out. I figured in the end, actually, that slug is seized, but it's probably been in its optimal position anyway. So I just tuned it from the primary side. And actually, when I did the alignment this time, I got quite a lot of extra volume out the radio. So realistically, I'm happy with the way that's set up. There's nothing on long wave, but I will try short wave with an antenna in the back now and just see if I can get any extra stations on there. Other jobs I need to do now. So I think I'll get the volume control done. This is quite loose, a little bit noisy. So I don't really like that. So I probably will change that. And we've got the Magic Eye to swap out, clean this up. And I want to look at that tweeter as well. And we'll come to that later on. So there's a few things to do. And obviously one of the RF generator aligns. Sorry, when the RF generator arrives, I'll get the RF alignment done on the FM stage. So yeah, a little bit of progress. I thought I'll get some little jobs out of the way. So I've cleaned up the front panel here. I'm not going to spray it. This is the colour it should be. I've cleaned up the keys and changed the Magic Eye, but this Magic Eye doesn't seem to be working like the other one. So it may be a problem with the circuit, maybe just two bad Magic Eyes. We'll look at that later on. So the radio's gone quiet again. So my plan was to go through the valves, really. I've got a full spare set and I've got some new ones as well. I've already changed the ECC 85, that made a little bit of difference on the radio. I'm informed as well you need a very good ECH 81 for the first stage of the FMIF. So I've got a new one of those. So I'm going to just drop that in and just see if that makes a difference. And I've got the two EF 89s from the other radio as well. So I'll give those a go just to see, one, if it reduces the noise, and two, whether it can improve the volume. And if it doesn't, then we'll need to get another plan in place. So I've been going through, just swapping some of the valves. I've got a new ECH 81 there. That didn't make any difference. Likewise with the EF 89. Actually, the one I put in, it's a second-hand tube. It's probably slightly weaker than the one I've taken out. So it's not really doing much in terms of improving the volume of the radio. But I'll just keep working through just changing these IF valves. I think fundamentally it's volume-wise, it's okay for medium wave. It's just on the FM, it's really quiet. So I'll just keep working through anyway. So I am struggling a bit with this radio. I changed the EL34 valve. I don't know why, because the radio is loud enough anyway on the AM, but when it did that, the dim bulb started to come in and the valve got really hot. So I swapped it back. I don't really think that's the problem. What's kind of concerning is the FM was really loud on one station, so I thought we'll improve the antenna. Now it's gone quiet across the board. It may need realigning because I did alignment without that capacitor in place. That might make a difference. So I do need to go through that process and also do the RF alignment when I get my signal generator. Looking at this antenna though, I do want to change this anyway. To me, this is an inadequate dipole antenna for FM. If you use any calculator for the FM band, these wire lengths should be about 76 centimeters each. These are about 30 centimeters each. To me, that's a completely inadequate antenna. So all I do, I'll get some nice thick wire and I'll make two lengths of 76 centimeters and just solder them on these points here and replace the antenna that way and just see if that improves reception overall. Okay, so while the signal generator is arriving, it's still in the post, and so I can't do the RF alignment at the moment. I want to turn my attention to this electrostatic tweeter. Now, I have been referring to this as a piezoelectric tweeter. That's incorrect. So every day is a learning school day, and it's in fact an electrostatic tweeter. The way this works is that a very large potential is placed across two plates, and in between those plates there's a membrane, and the signal is applied to that membrane, and that causes it to vibrate with the audio frequencies, and that's how you get the speaker effect. The problem with these are that they're fundamentally foam inside, and that foam just rots out. So I need to check that this is working. So if we look at the diagram, so this is what caught my attention actually about it being an electrostatic tweeter. There's actually 260 volts applied through this resistor to the top of the tweeter there. So I was wondering about that very high potential. And the audio frequency signals thread through this capacitor at this point, so that kind of does the variation there. So so that's how that works. So you can repair these. You need to drill out these spots here, then it will come apart, and then you just replace the rotted foam with new foam bits, and then put it all back together and just seal it up with a little bit of just melt the plastic slightly. It's hit or miss. So I don't really got anything to lose by if it's not working. Well, actually, if it is working, I'll just put it back in. If it's not working, then I need to decide whether I really want to try and even attempt that. I guess I've got nothing to lose, but there are alternatives. So this is the VHF 64. This actually shares the same chassis with the RG66. And in fact, the circuit diagram's on the other side here. So when you look at the circuit here, there's no electrostatic tweeter in there. What they do for a tweeter is actually a more conventional tweeter that's actually just on the AF side. So this is a 4-inch speaker. I don't know what impedance that has, but there is the option of just replicating this circuit with a modern tweeter. So in that respect, it's an authentic repair in the sense that the RG66 does use that methodology really for providing that tweeter. And if that's too loud, I can just put a power resistor in series there to drop the sound. So there are definitely some options. In a lot of respects, I think this might be a better quality sound. These do have a good feedback about these. People do like them. The other criticism I heard is that the directionality of the sound is pretty much straight on, whereas a modern tweeter might spread it out a little bit more. So yeah, we'll have to look at the results. So how do we test this? Well, realistically, you need to go back into circuit with the 260 volts across it. So what is the recommended approach is to put it back into circuit and then just take the main speakers out and just replace them with a dummy load. And then you can just test the tweeter. It should produce a high tinny pitch sound, because it might even make any difference with my ears, because the response of these is about 7 kilohertz and higher. So I might not even notice it, but that's what I'll do. I've got the speakers are 5 ohms, they're in parallel. I've actually got 2 5 ohm resistors here with plenty of power. So I'll put those in parallel, really just replicate that speaker arrangement, and then we'll just have we'll pump a signal in, and we should just have the tweeter working. So we'll just establish that way whether it's working or not. So that's what I'm going to get on with now. Okay, so I've got the radio turned on. The gram switch is selected, and I've got a signal generator tied to the gram input. I've got the dummy loads in place and the tweeter in place. It's just the back here. So that's all ready to go. So I'll just turn the signal generator on and turn the amplitude up, and let's just see what we've got. So that's actually set to 1 kilohertz at the moment. Let's bring the amplitude up. I don't know if you can hear that. It's just there. So just going to bring the frequency up. It's coming in a little bit stronger. It's up to 1.6. So that's 3, 4. It's coming in nice and strong. This is working. Really pleased. For me, that's starting to tail off. With my old ears, I'm not sure if I can hear this. Young ears on the video might be able to pick this up. I bring it up to 8 and 10, finally 12. So yeah, for my old hearing, I don't think that's going to make a lot of difference. But the point is the tweeter's working, so I'm not going to go in there. It's just going to go straight back into the radio. So I'm absolutely delighted with that. I will leave part 5 here, and this radio is taking quite a while to complete. I'm only making small increments forward in terms of fixing the particular problems. I was hoping when I found that fundamental issue with the VHF that the radio would just kick into life. That's not to be, although I am getting some volume there. It is very quiet, so there's still some work to do. I feel the AM is done, and also the electrostatic tweeter is working, so those are good bonuses, but there still seems to be a fair way to go. So yeah, I'll leave it here and pick it up in part 6. If you do like these videos, then please do subscribe, like and share. It's very much appreciated. I do look forward to reading all your comments. So bye for now.